Our first talk today is by Walter Schaeken. I know I didn't pronounce it correctly, Walter. I'm sorry. Richard said it much better, and I'm sure others can do it much better. But Walter is a professor at the Faculty of Psychology and Educational Sciences at the Catholic University of Leuven. Before the talk, I asked Walter how he got to know Ira. And then I also asked Ira how he got to know Walter. So it's a little bit like a best man looking for stories. Now, both of them said that they know each other from quite some time ago. Just how much time, I won't say. But they both belong to that rare breed, which is the psychologist of reasoning. And Ira recalls that they were in different sides of the debate between the mental models and the mental logic approaches to reason. But Ira felt, he's been telling me that Walter and he had much in common, not least that they were much more conflict adverse and much more keen to converse than some other people engaged in these debates. And of course, they both were interested in grasping pragmatics. And that is usually the case. I think Richard really made this very clear. There was also a human, there was a catalyst, which was a person who worked with both of them. And that's Jean-Baptiste van der Henst, who did his PhD with Ira. Ira was his supervisor. Then Jean-Baptiste, thanks to Marie Curie fellowship that he was awarded, did his postdoc in Walter's group in Leuven. Then Walter invited Ira to the International Conference of Thinking in 2004 in order to sort of like bring pragmatics to the spotlight for the reasoning world, thanks to Ira. And since then, they've been in touch very regularly. Now, I would say that Walter and his colleagues were among the first who engaged really scientifically with the idea that Ira and his colleagues were putting forward, that implicatures required effort. And they conceptualized of this as cognitive load and working memory resources. And then they operationalized this using the dual task paradigm. Now, the Denise and Schaeken paper 2007, when people are more logical under cognitive load, dual task impact on scalar implicature is a very much cited paper. And it's inspired a lot of work using this paradigm and variations of this paradigm. Funnily enough, Walter and I have never worked together directly until recently. However, they're currently doing some experiments together on the understanding of numbers and cognitive load. So these 20 years, at least 20 years of collaboration and conversation might be crowned by a jointly authored paper in the near future. Today, we have the chance to hear from Walter on preparing some talks requires effort.
Okay, I'm trying to share my screen. Let's see if that works. Always a tense moment. Is this working for you?
Yes, it works.
Okay, fine. So welcome, everyone. Thanks for inviting me to talk about the famous paper of Ira. I have a lot of slides, so I'll start immediately so that Napoleon doesn't run into trouble immediately. So I start classically with where did I meet Ira for the first time? And it was in this lovely building that I met Ira for the first time. Although it's not the real Ira that I met here, it's the MRC APU Cambridge building where I did meet Ira in the library that is in the form of a preprint of a paper, Sources of Difficulty in Deductive Reasoning, the Thought Task. It was a paper of 1990. And you see, we are not extremely young anymore, and we have a long history in reasoning. And I did find it a fascinating paper. And for those who do not know what the thought task is, it's the following. I have picked one color, black or white, and one shape, square or circle. A symbol that possesses exactly one of the properties I've picked is called a thought. The black circle is a thought. For each of the other symbols, are they a definitely a thought, undecided, or definitely not a thought? And so we have here 4 symbols, and the black circle is a thought. And I will give you a few seconds to think about it. I should be quiet when I give this this time to think, but of course in a well-timed talk, that's not possible, but so you at least could think a bit. And I'm pretty sure that you are convinced that it's a hard task, and it's indeed a very hard task to do. Just to help you a bit, the black circle has exactly one of the properties, that's the definition of the thought. Hence, properties are either black and square or white and circle. Therefore, the opposite of the black circle is also a thought, and the two symbols at the ends are definitely not thoughts. So a typical classic reasoning problem. I was trying to do some research on thought as well, but it never left my office. But so that's how I got to know Ira. I will come back to it later. Let's now start with the real start. That is a promising new experimental domain that is discovered and systematically explored. And that's, of course, the paper of Ira about which we are talking today. And it's already mentioned partly by Napoleon in his introduction. And I have to thank for this discovery of the paper Jean-Baptiste van der Henst, who was at that time in our lab. And also these four people, two people from logic, two people from linguistic, Hans Messart, Willem van Belle, Leon Horst from logic, and Mark de Neckere from computer science. We had at that time a collaboration on conditional reasoning, but we then ended up also with pragmatics, and these two things together brought me to the work of Grice, and therefore also to the work of Ira. And this is just a brief summary of the paper of Ira that we are talking about. The experiments presented here aim to establish the anticipated psychological reality of Gricean implicatures by investigating a paradigmatic case, scalar implicatures, largely from a developmental perspective. The experiment succeeded in demonstrating not only that these Gricean implicatures are present in adult inference making, but that in cognitive development, they occur only after logical interpretations have been well established. So that's a brief summary of the paper with the words of Ira. So let's now go to the middle, the real part of my talk. And I have a long subtitle next to the rather boring, the middle. And that's my take on one aspect, which, however, turns out to be quite unsatisfactory in the end, albeit interesting. Okay, so we start with a paper mentioned by Napoleon already. It's the paper together with Wim Denijs, where we started to do research with implicatures in our lab. And at that time, we were working, a lot of work was still in the reasoning field, and we were using the dual process theory. And at that time, and still, to be honest, there are different forms, different theories, which are called dual process theories, but they still have the same background idea. That is that there are two different cognitive systems. There is one system, which is quick, emotional, irrational, automatic. And there's another system, which is slow, conscious, logical, analytical. Now, if you look at dual process theories and you connect it to scalar implicatures, what was known at that time, you can come up with quite a nice story. That is, an often made claim in dual process theories is that automatic responses are easier, and therefore they're often given by children, and they're also produced faster by adults. Now, that was, of course, very nice to read if you dig into the scalar inference literature, because you have the Novak 2001 paper, where children favor logical interpretations, which then is in line with the idea that the logical interpretation is automatic. And the two follow-up articles, you could say, where it was shown that pragmatic responses require more time. Again, in line with the idea that logical interpretation is automatic. So Wim and I took this and we said, well, probably a good idea is to test this more directly with a popular experimental test of automaticity often used in dual process theories, that is dual task methodology. And the idea is, again, quite simple. You're interested in the original task, so you present the original task to your participants. However, you also present something else, an extra task. And because you present an extra task, there is, of course, less capacity left for the original task. So consequently, you have to rely a bit more on automatic responses. And so this means that basically you have two potential outcomes for the original task. One potential outcome is that there is no effect of the extra task. So that if you compare the original task solved on its own versus together with the extra task, the outcome is the same. That means that the original task was probably performed on the basis of automatic processes. It didn't suffer from the load that you put onto the participants with the extra task. However, if there is an effect of the extra task, so if together with the extra task, the original task now is performed worse, that means probably that the original task was not performed on the basis of automatic processes. So it's a very simple, straightforward idea. So what we did was very simple. We gave participants a sentence, and there were some filler items. There were typical underinformative some sentences, and they had to say whether or not that sentence was true. And at the same time, we were burdening cognitive resources during this task. So what are the predictions? Well, so we have a sentence like some tigers or animals. So we focus on the underinformative sentences. So some tigers or animals. Well, if you are what you can call in the defaultist camp, that's the term I think we used in that paper at that time. So when you think that pragmatic interpretation is the default one, then you expect more pragmatic answers under load condition, because that's the easy, the automatic response that you give. On the contrary, when you are a contextualist, when you think that the logical interpretation is the default one, then you expect fewer pragmatic answers under load. And so that's the simple idea that we tested. So the load manipulation in a bit more detail, we used the classic central executive load devised by Miyake and colleagues, the dot memorization, which is the following. You present to participants 3x3 matrix, and in this matrix you show either 3 dots, that's the low load condition, or 4 dots, that's the high load condition. Another difference is that in the low load conditions, the dots are always on a line, horizontal or vertical, while with the high load condition, that's not possible. There's always a bit of a randomness in the pattern. And so for a participant, the situation is the following. They receive for a very short period of time the dot matrix, then the dot matrix disappears, the sentence appears, and they have to come up with the evaluation of that sentence, some tigers or animals, yes or no. And then after the answer, an empty grid appears, and I have to point where in the original dot matrix the points, the dots were presented. And that's the end of one trial, and then the next trial starts with a new dot matrix, a new sentence, and so on and so on. Okay, so that's the methodology. So what were the results of this paper? The results were quite clear. If you look at the filler items, there was no difference between low and high load condition. So in principle, the load condition was not that heavy, that difficult. However, if you look at the underinformative sentences, you saw a nice effect of loads. That is, under load, so in the high load condition, participants produced less pragmatic responses. So what does this paper tell you? Well, burdening cognitive resources leads to a decrease of pragmatic inferences. Importantly was, the effect is small. The effect was about 6–7% drop. So it's not that there's a massive effect, but there is an effect of the load. So you could say that a bit contrary to the intuition, and just to mimic the title of the paper of Ira, people are more logical under cognitive load, which is a bit strange maybe at first. But of course, it fits very well with the idea of the contextualists who say that, well, you start with a logic interpretation, and it's when needed with inferences, you come up with a pragmatic reading of the sentence. So implicatures are costly, therefore you produce less implicatures under load. So that's, you could say, the starting point of our work on working memory and implicatures. Few years later, we published another article together with Christine Dessart, Verkerk, and Gillard, And this was building on the work of Wim and I. And so what we did here was we tried to think of a potential criticism that basically we ourselves had already as well. That is, we just gave the same load to everyone, not thinking about potential differences. While I think it's worthwhile to think that there might be individual differences in working memory capacity, and that might have an influence on the data. Especially since we observed that there was only a small effect of load. And I think that it makes sense to predict that, well, when it's only a small effect, load has only a small effect, then this probably is only there when you look at people rather low in working memory capacity. When you have a lot of working memory capacity, this load probably doesn't hinder you. That was the hypothesis that we had in the paper. And so what we did was basically we did a replication of de Nijs and Schaeken, but additionally we measured working memory capacity. So what were the results of this paper? This is when you just look in general, you see a massive drop from low load to high load. But to be honest, this massive drop is of course is helped a lot by the y-axis, which is going from 64 to 71. The drop is indeed, again, small, but significant. And you give less pragmatic responses under high load conditions. So we replicate here de Nijs and Schaeken. The effect is a bit smaller, but still significant. Now with a more honest y-axis, and now results in detail where we look at the three working memory groups. So we have a low working memory group, a medium working memory group, and a high working memory group. And so what you observe is that for the medium and the high working memory group, there is no difference in high load versus low load condition. However, importantly, there is a drop in performance from low load to high load for the low working memory group. So that means that the results were clearly in line with our predictions. That is that the high load leads to less pragmatic responses. However, this is only the case for people with not so much working memory capacity. So far, so good. However, there is a problem with this data as well. That is, if you look at the pattern of the three working memory groups, this is a bit weird because what you would expect is something like this. That is, you would expect that if the low working memory group have more problems with coming up with pragmatic responses due to load in the high load condition, that in general they would produce less pragmatic responses, while they produce more than the medium group, for instance. So one part of the data, okay, the other part of the data, hard to reconcile with the other stuff. So brief discussion. So in general, we replicate de Nijs and Schaeken. If you look at the data a bit more in detail, there is one positive point, that is the effect of de Nijs and Schaeken is as predicted only present in the low working memory group. But there is also an important negative detail in the data. Well, you can debate if it's a detail. That is that the trend of the groups is unexpected and contrary to what you would predict if you look at it. That is, you would expect that low working memory group would give fewer pragmatic responses while they give many of them. Okay, let's move now to third paper, again about 4 years later. And it was again inspired by this individual differences idea, but now we broadened. So we not just wanted to know only about working memory, but about more factors where people could differ on. And we hope that this could provide more insight as to why people vary in their interpretation of scalar terms. So the experiment again was very simple. That is, we gave them a bunch of scalar inferences with some, as in the previous papers. And we also measured working memory capacity like before, but additionally, we measured the ability to override an intuitive default, because that's at least one of the proposed mechanisms, that you start with a default that if needed, you override. we measured autism spectrum quotient, because at that time there were already some papers pointing that people with autism might suffer with scalars. And exploratory, we also looked at the big 5 personality traits. So our research question was that if you look at the results and you see that there are some pragmatic people, there are some logical people, or then there are factors which can predict that they are indeed pragmatic or logical. That is, or the response times, the cognitive variables, the personality variables, or they somehow related to the interpretation mode of the participants. And to do that, we used a rather new technique at that time in the field, that is latent class regression, which allows to add covariates to predict the probability of a latent class membership. So what we did is, with this technique, is in the first step, you look for latent classes in the data, in this case, with respect to the answer they were given. So we didn't have to think about criteria, just let the data speak. And the 3-class model was giving the best fit of the data. And I think that if you see these numbers, it's quite clear what the 3 classes mean. So we have class A with a probability of 0.94 to give a pragmatic response, class B with a probability of 0.05 to give a pragmatic response, and then a class C, which is 0.664 to give a pragmatic response. So the idea is very simple. If you look at the data, what you have is you have a pragmatic class, you have a logical class, and you have a sort of inconsistent class. And so the next step is then to do a latent class regression, where you see if one of these covariates can predict class membership, can predict whether or not someone is falling into the pragmatic class or in the logical class. Well, what we observed with this technique was that neither the cognitive nor the personality covariates could predict class membership. Also, response times to the control sentences were unrelated to class membership. The only effect that we did find was that response times to the underinformative sentences did predict membership. That is, that the probability of belonging to the logical class increases with the reaction time on the underinformative sentences. So the idea is that the faster participants respond to underinformative sentences, the more likely they are to interpret these sentences consistently. And so, well, this is a graph showing this. So reaction time is on the x-axis, and you see that you have a higher probability belonging to the, if you look at the black line, to the logical class, if you have a fast reaction time. And you see also that the longer reaction time, now you have to look at the dotted line, is more linked to the pragmatic class. So what these data seem to indicate is that neither working memory capacity nor people's ability to override default are predictors of class membership, which seems to indicate that the cognitive costs in finding a pragmatic interpretation, finding alternatives, or canceling one reading to another reading, that seems to be at least limited. There was also no effect of personality traits in general with the big 5, but also not with the autism quotient, which was then a bit contrary to what Nieuwland and colleagues did find. What we did observe robustly was that pragmatic inferences are related to longer reading times. And that's also found by a paper that I had together with Bob, where we did observe the same for some sentences, but not for other quantity implicatures. Okay, so first intermezzo in the middle part of my talk. It's about important future work, maybe also for you, dear audience. So what is this important future work? If you look at this, you could say it's a rather disappointing series of own articles. The first one, you see nice effects, and then it's a bit complicated, and then it's even more complicated in manuscript 3. And the funny thing, of course, is that the first paper is cited a lot, the second paper is cited okay, the third paper is almost not cited. And that's, I mean, I don't I don't feel perfectly okay with that. And I think it's good that you look critical at these 3 papers and think, well, how can I reconcile this? And I think that being critical, also being self-critical, is important in science. Now, I'm not someone who invented that self-criticism is important. I also don't think that Ira invented it, but Ira showed it already in his 2001 paper, because in the introduction, he was saying, although the notion of implicature may come up often in the reasoning literature, it is typically treated dismissively in one of 2 ways. And then he's citing one of his own papers to show, hey, that's a paper where they didn't do the job very well. So I learned it from a good guy, this self-criticism. Now I can look at my own papers. When you look in the literature, you find more or less the same paper. You find some papers where you find some effects on sentences with some, and you find some papers where you don't find this effect on some sentences. Marty and Chamla, for instance, they did find the effect. Feeney and colleagues, they didn't find the effect that I was talking about. This is just, I just mentioned here 2 articles, 2 names. So what we are currently doing is we're doing a systematic review and meta-analysis on empirical papers about scalars and working memory. And here comes my invitation to you and maybe the work for you. We want to include also solid experiments, which, however, never left the office, maybe left the office for a while, but then were not accepted in a journal because, for instance, null results were more difficult to publish. So if you have unpublished but good experiments on working memory and implicatures, please contact me, just send me an email, and then we can see how we will deal with the data. But I think it's important that we try to figure out really, is there now an effect or not of working memory? So that's the first intermezzo. Second intermezzo, there is more in NOVEC 2001. Indeed, because now I was only talking about sentences with some, but if you look at the paper of 2001, well, the first experiments were not about some, they were about might and must. Moreover, Ira was not using one method. In the first experiment, he was using a sort of reasoning experiment, truth table task. Then there was a training task, and then there was a truth value judgment task. Third, he was not focusing on one age group, he was really using the developmental spectrum. And I think that's really important, that you just are not solely focusing on one thing, that you do more like Ira did. So now comes the middle, the sequel, my take on one aspect using the more of NOVEC 2001, which still turns out to be quite unsatisfactory in the end, albeit interesting. So to summarize it a bit and not to use a lengthy subtitle, I will talk now about different age ranges. We published in 2014, together with Janssens and Fabry, a study about small children and working memory, the 5.5 years old. So we measured working memory of them with the WISC, and at the same time we gave them 2 tasks, and this was inspired by the work of Pusculus. We gave them a truth value judgment task like before, but Pusculus argues, rightly I think, that if you think about this task, you have a sentence, you have to remember it, and then you have to evaluate whether or not it's true or not. This kind of meta-linguistic evaluation is probably definitely for small children, requiring some working memory capacity. So there is some working memory load in this task. While a task where they have to do things, only have to do things, is probably less load requiring. So what we did is we gave our kids one of those action-based tasks and a truth value judgment version of it. So action-based task of Pusculus, I think that most of you know how it works. So you have a bunch of boxes in front of the kids, and they can contain marbles. In this case, it's called the all scenario. In this case, all the boxes have a marble in it. And then you give a sentence and a task, and they have to perform this task. In this case, I would like some boxes to contain a marble. Now, in this case, you could do nothing because some is compatible with all. But of course, the pragmatic response is to do something, and this something might be to take away 3 marbles. And then, of course, this is just one item. Then you have also the some scenario, the non-scenario, etc. And you have also other sentences. So that's the axiom-based task. We also did a truth value judgment task. Normally we work with nice pictures, etc. But here we had a quite dull truth value judgment task because we wanted it to look at the other one. So we had similar boxes with marbles in it. And then we describe the situation, like in this case, some of the boxes contain a marble, and then they have to say whether or not this was a good description. What did we find? We replicated Pusculus, that is, the axiom-based task was easier than the truth-value judgment task, clearly both on the control items, but especially on the under-informative items. So you could see this as support for the role of working memory, because a truth-value judgment task requires some working memory load. However, there was no reliable effect of our working memory measurement. In general, there was a better performance if working memory was bigger, but the trend was not significant. We did 2 extra experiments also in the article, and the picture was confirmed. So to summarize, like with the adult data, these small kids data also the results were mixed. That is, we confirmed the expectation of a worse performance on the more difficult task, but we didn't find a reliable effect of working memory. Let's turn our attention now to the other side of the spectrum. Together with Valentina van Looyen de Middelen, we did a study with what is in the literature sometimes called older old adults. So with really old participants, mean age 84. And we were looking at the role of executive functions in pragmatics. And so we presented inhibition, working memory, and cognitive flexibility tests to them to measure these executive functions. And we did a comprehensive test of pragmatics by means of the APAX, developed by Valentina and Giorgio. And at the same time, because implicatures are not part of the APAX, we also give them a list of implicatures. Now, if we focus on the implicatures itself, what we observed there was that working memory and cognitive flexibility were the most important predictors with a more or less comparable weight for performance on underinformative sentences. While the role of inhibition was there, but only very, very small. If you look at the APAX data in general, a more or less similar picture seems to arise there. But so again, focusing on the implicatures, what this seems to mean is that for the older old adults, working memory seems to be important, in line with the idea that we proposed in the Jussard paper, that especially for people who are rather low in working memory, and that's the case with these older old adults, there seems to be this important role of working memory, and they might suffer more from load situations. Step 2 of the sequel of the middle, the sequel of the sequel. Let's talk about clinical populations. Together with Martien Wampers and some psychiatrists, we looked at people with schizophrenia and psychosis and how they performed on implicatures. And this was inspired by work of, for instance, Valentina, which shows that pragmatic abilities are widely compromised in people with schizophrenia and psychosis. But in that work, again, implicatures was not part of it. So we did 2 experiments with implicatures with some, a binary judgment task and a ternary judgment task. The first experiment, the binary judgment task, in the filler items, there was no difference between the patients and the controls. For the underinformative sentences, this is the only statistic that I show in this task. There was no significant difference between the control and the patient group, although it was almost different significant. If you look at the control group alone, you see that they gave more pragmatic responses than logical responses, while there was no difference in the patient group with respect to pragmatic versus logical responses. In the second experiment, where we used the ternary task, so where instead of just having false and true, you also have this middle option. It's not really true, but also not really false, task devised by Napoleon. What we observe here is that on the control sentences, there was no difference between the two groups. There was no difference with respect to the middle option, but with respect to two extremes, there was now a difference between the two groups. That is, the patients gave more logical responses than the controls, and they gave less pragmatic responses than the controls. So now we did find a nice demonstration of less pragmatic responses in the patient group. Before we yell hooray, hooray too loud, we have to acknowledge that if you look at the controls, the amount of middle option answers is surprisingly low, but that will not go into detail here. But so summarizing, you could say that experiment 1 is giving weak and experiment 2 is giving quite strong evidence for fewer pragmatic responses for patients with schizophrenia and psychosis, which is in line with the idea that there is a pragmatic deficit, which might be a core feature of schizophrenia. Recently, we published another paper, more or less the same team as before, where we replicated the previous study, but now not only with some sentences, but also with other scalar terms, and we measured working memory. And the results are, I think, at this point in my talk, not unexpectedly quite mixed. That is, we observed scalar diversity in both groups. So both the clinical and the control group showed nice scalar diversity in line with predictions of Bob van Thiel's work. And in this case, disjunctive and quantifier items were treated more pragmatically than the adjectives. That's what you can see here. So you see that the green and the purple bar are higher, especially if you look at the average. So the black line in these bars, you see that they are treated more pragmatically than the others. So you see also scalar diversity in the patient group. However, there was no reliable difference between patients and controls with respect to quantifiers. The effect was there, but it was not significant. We did find an effect of working memory this time again, however, only in a subtle way, meaning that we didn't find it for the quantifier items, but we did find it for the disjunctive items, which were solved less pragmatically by the people with lower working memory capacity. So mixed results again. Now, the final sequel of my middle section, other terms, I mentioned it already in the previous one. We used some other terms. We also did research with really something else, that is with but sentences. And we looked at but and the effect of working memory. Because but, I think it's really an under-researched word in the field, because it has a nice mix of conventional and conversational implicatures connected to it. I will not go into detail, just illustrate it briefly. In a sentence like he's strong but anxious, you could say that, well, it's basically from a truth functional point of view, it's similar as he's strong and anxious. But of course, what you add is some sort of contrast. And you cannot get rid of the contrast between he's strong and anxious. That's the idea of but, so the contrast. But there is additionally, apart from this thing, which is in the meaning conventionally of but, there is also a cancelable difference in weight between the P part, the first part, and the Q, the second part of a but sentence. And let me illustrate this with another example. Compare the milk is sour, but I'm thirsty, with I'm thirsty, but the milk is sour. So two similar sentences. Only the order is switched. I think that you will agree with me that the intuition is that if you have to complete these sentences with so sentence, that you will say the milk is sour, but I'm thirsty, so I will drink. While in the second case, I'm thirsty, but the milk is sour, you will complete it with so I will not drink. Important, this fact that you continue it on the basis of what is in the second part. So the second part in the first sentence is I'm thirsty, so that has more weight, so you will drink. For the second sentence, the second part is the milk is sour, so you will not drink. However, this extra weight of the Q part of the sentence is cancelable because we even have a word for it. The milk is sour, but I'm thirsty. Nevertheless, I will not drink because I'm afraid of. I'm thirsty, but milk is sour. Nevertheless, I will drink because I don't want to dehydrate or something. So what we did is we had participants to complete P but Q sentences followed by so and nevertheless, and we burdened working memory experimentally. We had, in this case, even 3 load conditions. What were the results? So completion of so was easier than completion of nevertheless. And with easier, we mean more answers were in line with this weight hypothesis. Again, it was a nice effect, but it's not that everyone was following this weight hypothesis. These are the data. So you compare then these but sentences with exactly the same sentences where instead of but, you connect the sentences just with a period. And you see that for the so sentences, there were indeed quite a lot more items which were then answered in line with the weight hypothesis, while with the nevertheless sentence, there was no significant difference with the period sentences. But in this case, there was no effect of working memory at all. And if you look at, because it was quite a complicated design, at all the interactions we had, in none of the interactions working memory appeared. And this graph, I think, tells it all. It was a flat line here, working memory effect on but sentences. And you see here the 3 load conditions. In general, no effect at all. Okay, so that was some work that we did on working memory and implicatures. How do I see now the future based on my experience with this work? Well, I think that the first step that we have to do is we have to do what we are doing now, and I think what we're doing good, that is we have to collect data. But when we do that, we really have to think about how Ira did it already in his first paper. That is that we have to think broad. That is, first of all, we have to use large enough samples, because when we work with small sample sizes, there is too much noise in the data. And I know it's difficult in developmental work, it's difficult in clinical work, but I think it's important to do that, because otherwise we have noisy data and that is just leading to noise in general. We have to use, as Ira did, a variety of methods. Also important, we have to precisely describe these methods so that we can replicate each other. And also when we describe our participants, we have to describe them precisely, especially for clinical studies. And I'm also guilty of this. It's sometimes so hard to get data from, or it's impossible to get data from psychiatrists about your patient. But in the end, it is important that we really try very hard to do this, just again, in order to be sure what we are finding. We have not to look at just one age range, we have to look at the whole age range, as Ira already started with, because I think there are clear indications that at different age range, we see different things. And so it's important to know what's going on there. We have to look for the whole range of a phenomenon. I did my first experiments only with some, because as a reasoning researcher, we know some from the syllogisms, and with some you could do some easy manipulations, etc. But it's not right to use only some. You also have to look at other terms. So we really have to do that. And I think we also have really to collaborate with different disciplines when we do this kind of research. A psychologist will think about things like executive functions, working memory, and stuff like that. Important. But a linguist, he will think about other things. Logicians, they will think about other things. Also important. They will think, for instance, about closed versus open scales, or they will talk about positively versus negatively oriented scalar words, or they talk about semantic distance, etc. All these things might matter. And so it's only through collaboration with these things that in this, I think, quite complicated field of pragmatics, we can really collect solid data. And the next step is to summarize these data. And again, I think that's what we are currently doing. I really think it's important that we do this again in a systematic way. And that's what we try to do now. So again, reminder, if you have data in your drawer or somewhere else, please contact me. And it's only when we have this summary of data that we know whether or not we have real effects there. Even if these real effects are small, then we know that, and that's also important to know. And we can also discover preconditions for these effects. Because what is important is that somehow we must establish robust phenomena. And we know, for instance, now I think there is one robust phenomenon, in pragmatics that Ira discovered with that paper that we are talking about now, that is kids are much more logical than adults under informative sentence. Working memory at the moment, hopefully within a few months, we will know whether or not will not be a strong effect, but maybe it's a small effect, maybe it's not. We don't know at the moment. But so we have to do this kind of work. Step 2, I think we have to develop verbal theories which are more or less easy to communicate to each other, which tell us what are the data, what are the components involved, what are the relations between the components which are involved, the mechanisms that we use. Can we identify causal relations? So we don't need only the first step, we have to do something. Because we want to explain and we want to predict, so we have to summarize these ideas in theories. Important is this first step, I cannot emphasize it enough, because at the moment, I think that maybe there are even not enough robust phenomena to constrain our theories enough. So data collection, although I think that theorizing at the moment is important, data collection remains important. And of course, there are, for instance, in formal linguistics, etc., there are already theories there. We have to look at these theories and use them together with the data that we have. Important as well is that we take into account the level of explanation. I think this is something that most of you know, but we have this distinction of MAR between computational level, algorithmic level, implementational level. And so the computational level is what is the function being computed by the capacity and why is it computing that? So it's talking about the cognitive, it's describing the cognitive function. The algorithmic level is describing, you could say, the cognitive process. It's how is the function computed, what algorithm is doing the work. And then, of course, there is the implementational level. How is it physically realized? And what is important to realize is that the lower levels of explanation are underdetermined by the higher levels of explanation, although they're constrained by it. So if you know something about the cognitive function, it's not that you know then what the algorithm will look like, because you can realize it in different ways. Well, this is just one example where a more statistical function is realized in different ways from a very interesting paper by Van Rooij and Blokpoel in different ways, and that this can also be physically realized in different ways. Well, I'll not go into detail here because I don't have the time. But why I'm saying this, well, if you think about Grice, Goertz, and Rubio Fernandez correctly, and Bob and I also mentioned it in 2016, Grice account is on the computational level. So he specifies what information the hearers are entitled to infer and how these inferences are justified. So he's really talking about the what and the why. He's not talking about how we were doing it, although it's tempting to do that when you read the work of Grice. Now, I'm a psychologist, so I'm especially interested in the how, but I think we have to acknowledge as well that knowing the what and why, so knowing the top level, you could say, is important, and you can then also make it less important by using interesting or helpful, but it's important if you want to make the how concrete. And I think that Marr was even very precise on this. He's saying that an algorithm is likely to be understood more readily by understanding the nature of the problem solving being solved rather than by examining the mechanisms in which it's embodied. So a precise grip on the computational level helps us to build a theory at the algorithmic level as well. And that means that we should work together, different disciplines. We have to read the papers of each other. And I think that we are an interdisciplinary field. And if we want to do this, we really have to collaborate. Step 3 is going even further. We have this verbal theory. Well, we have to formalize it. What does it mean? Well, it means that we have to find a formal language. It can be mathematics, it can be logic, it can be a sort of programming language, which is, yes, less intuitive than verbal theories, but it will enable us to make precise deductions about behavior implied by the theory. And currently there's some work which is doing that. I think it's really nice that we try to do that. because verbal theories are typically imprecise and vague, and therefore exact predictions are often difficult to make. And Ira mentioned this already in the 2001 paper. And so in this paper, for instance, he said, nevertheless, Grice's construct must largely be validated. Then he goes on, its weakness is that it does not predict the specific kind of implicatures produced. And in another part of the paper, he said, our evidence is compatible with either the neo-Gricean or the relevance account of scalar implicatures, because the theories were not precise enough. Of course, when I talk about these three steps, it's a simplification. So you have step 1, step 2, and then step 3, and then there is a interaction between these different steps. This is a nice recent paper about coming up with the formal theory. It's a bit more complicated than just 3 steps, but the 3 steps are, I think, something we have to keep in mind in the future. I think experimental pragmatics will really gain a lot from it. Important to keep in mind, I think, is that complex statistical, logical, mathematical, computational, whatever kind of models will not make pragmatics more scientific if the empirical basis is not solid yet. So we need robust phenomena. So we need still good experimentation. And similarly, concepts can only serve as the basis for theories if they are clearly and transparently defined by the authors, if the different ways of measuring them are validated enough. So this is my plea for high quality method sections and result sections in manuscripts we submit to journals. I think this is a service that we authors can offer to the field of pragmatics, and that this will lead to more phenomena which are needed for better theories. Also important to keep in mind, because this might sound maybe a bit negative, is this quote of Isaac Asimov. People think that scientific theories that aren't perfectly and completely right are totally and equally wrong. In fact, good concepts are gradually refined and extended. Supplanted theories are not as so much wrong as incomplete. I think that each attempt on the basis of solid data will help us. And we did already a number of these things in our field. And when we do this, we have to make many choices that have an influence on subsequent steps. So we might go wrong somewhere or take a side step which was unnecessary. But there is at least already some progress. And I think in the field we do well. And what I really think is very important for this field is that we had this collaboration between people who were not having the same ideas. And this really can help us a lot in building better experiments, better theories. And so the network like XPrag, inspired by Ira, I think is a crucial importance for pragmatics. So to end, back to Ira's history. So what I'm claiming is that to have a complete account, we need theories which are precise, and we need robust phenomena. So a complete account is looking for the 2 of them, not just one of them. Now, if you go back to the beginning of my talk, how I met Ira, that was with a thought task. And what is a thought? Well, it's a symbol that possesses exactly one of the properties I've listed. That's a thought. So a thing that has only one of these properties. And that's not what we want. We want researchers paying attention to both. So good, Ira, that you stopped doing research on thought. You only published 1 paper on it, because in pragmatics, we want less talks and we want more Iras. Thank you.